basic one. There's a block. That surface is rough. Now I'll apply an horizontal force. I'll press the block against the wall. Then here the weight mg will act. Then a normal contact between them. The wall will exert force. In turn, what happens? The block will exert a force on the wall. Then I see that the block is at rest. So somebody should balance weight. That is what the friction. And the friction by the block on the wall will be like this. Then what should be the minimum value of F for which the block will be at rest? Minimum I asking. Find the minimum value of F for which the block will be at rest. And then we'll provide normal contact. The normal contact is given by n minus f equals 0. So n equal to f, that one. Then for the friction to balance, f is equal to mu n. So this will be mu f. Then the friction should balance mg for equilibrium. So what is value? This will be mu f minus mg equals 0. So what is f equal to? Mg by mu. I'll call this as minimum. If you apply force less than this, the block will slide down. If you apply force more than this, will block will slide up? No. Because what is the maximum permitted value of the friction? Friction cannot be greater than mg. So here I'll put condition that one, F greater than or equal to mg by mu, block will be at rest. F less than mg by mu, block slides down. So now this will be really little bit confusion. As I increase applied force, so n will increase, then the friction can be greater than mg. On paper, mathematics okay, justify that. But practically, you press how much of R you want, the block will never slide up. You can try in your home. Take some compass box or notebook, no? Press against the wall. As you press this against the wall, as you apply some minimum force, it will be at rest. Less than minimum, it starts sliding. Once as you press hard, it can never move up. It can never slide up. But mathematically what it says, according to this equation, as you increase capital F, then the friction force will increase. Then the friction force can be mg and it slide up. Okay, on paper, everything fine. But practically what happens, you press how much of R you want, the block can never slide up here because the friction cannot take the value greater than mg. What is this about the equilibrium? So there's a minimum force, I'm telling that one. So as long as your force applied is greater than or equal to mg by mu, block will be at rest. Less than, it will slide down. But no question of sliding. Got it, no? So this is about pressing. If you want, you can try now only. Just press the notebook against the wall and check it. You press with a force, a little bit less force, and slides down. Then at one force, it will be balanced. Further, if you press hard, it will not slide up. Now, if I apply force at an angle, now what are the conditions for this? So we applied a force at an angle. So what are the forces they'll be acting? Mg. I'll give another diagram. The weight mg will act. The component of the applied force. So here the friction and the friction on the wall. The normal contact, this will be n, this will be n, this will be how much? F sine theta, and this will be F cos theta. So what is the normal contact? It will balance it by n minus F sine theta equal to 0. So what is friction? Mu n. F equal to mu F sine theta. Then for vertical equilibrium, F plus F cos theta minus mg equal to 0. Let me substitute value of F. This will be mu F sine theta plus F cos theta minus mg equal to 0. This should be mg by cos theta plus mu sine theta. If I apply force, so there are definitely two situations are there, no? If F cos theta, I brought the value of F. If F greater than less than, I think the direction of friction can change here. Its possibility is there, no? What we assumed is there's a minimum force, I'll put it. Then similarly, if maximum force, if I apply it, I think I'll start with the minimum. Let me put condition this minimum force. The block, what happens, somehow what happens, I can retain it. If I increase the magnitude of force, then what is the direction of friction? Let it be like this. This is the minimum force. Now I'll keep on increase the magnitude. Then at one specific value, the friction will change the direction. The friction will change the direction. So you can see the both the cases. Now I'll apply maximum force. Then the equivalent thing. The friction here, I'll change the direction. This will be mg. Both the conditions I brought at one place, do make observation. And then what about the normal contact? This will be n. This will be n. What is this force? F max sine theta. And what about this? F max cos theta. What is n? N minus F max sine theta equal to 0. So then along y-axis, F max cos theta minus mg minus F equal to 0. And I'll solve it here. So this F max minus mg, what is F is equal to mu n. What is n equal to? F max sine theta. So value of F max equal to mg by F max cos theta. This is a F max cos theta. So this should be cos theta. Now why I should call maximum? You can see denominator negative sign. Here it was positive sign. Are you looking at this? Both the conditions I brought it here. If you apply force greater than F max, the block will slide up. If you apply force less than F minimum, the block will slide down. As long as the force is between F max, F minimum, the block will be in equilibrium. You can say this one. So when you apply force at an angle, then the maximum minimum idea will come into picture. Okay, this is about the friction. So let's go for, if there are, I can apply force in not only this, I can apply in even in some other directions. Just do make observation. I'll bring the different cases here. Completed. So I'll go for next one.